I said earlier, there's a second method of solving this question, but might take time. The second method works on the fact that for a system to have infinitely many solutions, the gradients of both equations and the y-intercepts of both equations would have to be the same. And writing a linear equation in a way that shows the gradient and the y-intercept is having it to be written as y equals mx plus c. M stands for the gradient and c is the y-intercept. So what you're meant to do to solve this question is to convert each of these equations to this format where you have y equals mx plus c. Although we already know the answer is d, so we can use it to explain. Let's take the first equation. You have 2x plus 3y equals 13. We have to rewrite this equation to look like this, where you have y alone on the left and the other values on the right. So you take the 2x away first. It's positive 2x. It crosses the equals sign, it turns to negative 2x. So you have plus 3y equals negative 2x plus 13. This 13 has a positive. And this 2x crossing the equals to sign with the positive it carries turns to negative. You can choose to write it first, so it looks like this, where you have the value with the x first before you have the constant. To make it like this, you have to make the coefficient of y 1. So you divide through by 3. So you divide by 3, by 3, by 3. So here, 3 will cancel 3. You have y equals negative 2x over 3 plus 13 over 3. That's the first equation written in a way that shows the gradient and the y-intercept. The y-intercept is where the line crosses the y-axis. And the coefficient of x, which is negative 2 over 3 in this case, is the gradient. That's the slope. Let's go for the second equation and convert it from this form to this form. We have the second equation as 4x plus 6y equals 26. We take the plus 4x over the equals sign, it turns to negative 4x. Standard in math, you say subtract 4x from both sides. It's still the same result. This 6y once is positive, so you have plus 6y, or you can write 6y equals negative 4x plus 26. This 26 has a positive, though it's hidden. So in this case, you have to write plus 26. Next, we divide both sides by 6, which is the coefficient of y, because we're trying to make the coefficient of y 1. So you divide this by 6, this by 6, and this by 6. This 6 will cancel this 6. You'll be having y equals, you can bring this fraction down. You have negative 4 over 6. 2 can go in both 4 and 6. 2 in 4 is 2. 2 in 6 is 3. So you have negative 2 over 3x. Remember, you still have the x plus, 2 can go in 26 and 2 can go in 6. 2 in 26 is 13. 2 in 6 is 3. So you have 13 over 3. We've also converted the second equation to a form that shows both the gradient and the y-intercept. Now, if you look at both equation 1 in the form that shows both the gradient and the y-intercept, and equation 2 that shows both the gradient and the y-intercept, you see that they are the same. Initially, they were not looking the same, but now they are the same. Let's mark them out. This is equation 1, and this is equation 2. You can see they both have the same gradient. The gradient of this is negative 2 over 3, which is the coefficient of x. Same as this, you have it as negative 2 over 3. While the y-intercept of the first equation is 13 over 3, and that of the second is also 13 over 3. That shows the system has infinitely many solutions. That the second line is on the first line, or the first line and the second line are the same. Hope you understand. Comparing both methods, that is the shortcut method and the standard method, you'd obviously notice that the shortcut method is faster. But that shouldn't stop you from studying both methods, because in some cases, the standard method might work better. So learn both.